Today class is high voltage DC transmission system. Okay. Also we know that what is the high voltage DC transmission and how it's operate. Also start it again. What is the high voltage transmission DC transmission system? Okay. Generating station and it is produced the 11 kV supply. Then we step up the 11 kV supply into 132 or high voltage DC. That's mean 232 kV or above. Okay. By step up transformer, then this AC power converted into DC by converter. Which type of converter convert AC into DC? Only rectifier. Okay, that's mean this substation convert the high voltage AC into high voltage DC. Next we transmit the high voltage DC by transmission line. Okay, and then again in receiving end side we also convert the high voltage DC into high voltage AC by converter. Which type of converter convert DC into AC? Inverter also. Then this substation converter substation, this substation convert DC power into AC power, and this AC power also step down by, this is also high voltage DC, and then we also need a low voltage for distribution. Then again we step down the AC power, high voltage AC into DC, high voltage DC, high voltage AC into this is low voltage AC by step down transformer in receiving end side, and then it distribute. This is the main concept of working principle of high voltage DC transmission line. Okay, today we will see that what is the difference between high voltage DC and high voltage AC. Okay, first of all we see that capital cost. Okay, in both extra high voltage AC system and high voltage DC system, we see that the capital cost, extra high voltage AC system capital cost is higher from the high voltage DC system, because of we see that in DC transmission line. Okay, this is the DC transmission line. We see that only one line is possible. No, if we in AC system we also see that the three-phase supply, for the three-phase supply we also need a three-phase line. Suppose three-phase supply need a three-phase R, Y, B line. Okay, but in case in DC we don't need a three conductor. Okay, so only one conductor and one earth wire. Okay, so the capital cost is much higher extra high voltage system over than high voltage DC system. Skin effect, we also see that skin effect in present AC system. Skin effect in present in AC system. In AC, the nature of current flowing surface of the conductor. Suppose this is the conductor, and the nature of the AC current flowing through the surface of the conductor. So skin effect in present in AC system. Okay, but in DC system we see that the current is flow throughout the conductor equal. Okay, so no skin effect is present in high voltage DC system. So skin effect here also present and high voltage system is absent. Ground return is not possible, but here also possible. Ground return means, here we see that the transmission line also transmit the one conductor. Okay, and ground return, that's mean the another conductor, that's mean the negative, you can take a negative conductor also return by ground wire, but in transmission line we see that no ground wire can be written, only earth wire. Okay, this is the suppose transmission line, and we also see the circuit. This is the earth. Okay, no ground return, this is the neutral. Okay, so no ground return is possible. Line losses also be in extra high voltage AC system is high, and here also be low, because we see that The skin effect is present also in extra high voltage system, not in this system, and others etc. Skin effect, Ferranti effect, that others losses. Skin and coronal loss is much higher in extra high voltage, so losses also be the line losses also be the high, and here also be the low. And what is the remarks? Only single bipolar high voltage DC line are possible, okay, in low losses. So next class we also see that what is the single bipolar high voltage DC line or other type of high voltage DC line in present in India. Okay, power transfer. If you transmit the power, from sending end side to receiving end side, then we need a follow the power angle. Suppose power angle means V into I. This angle also is the maintenance because of power factor. Okay, because of power factor we cannot vary the VI. We also have fixed VI or control the VI. But in case in DC line we don't need a limit of power transfer, because here also no present angle between V and I, because V and I don't angle present because of no magnitude of current. Voltage control difficult for long line due to series inductance and shunt capacitance. That's mean in transmission line we also see that this is the line resistance R XL, and with suppose this is the load, this is the sending end or VS, we see that the XL and capacitance XC are present. For due to the line control the voltage regulation is difficult, and for high voltage DC system is easier. Okay, corona and radio intervention is more here because of this AC. The corona also be higher than high voltage DC, and here also be the less. Reliability also lesser because all type of losses are present in extra high voltage system but not in DC system. So reliability also the higher of a high voltage DC system over than extra high voltage AC system. AC current is large, short circuit current is large here, and here also with the less. Control system is simple, cheap, and limitation of control. You cannot control easily for here, but high voltage DC system control system is difficult, costlier, but taste and accurate control. Okay, because of if you see that here control system is here present and also be here is present. So two control system are in a transmission line are present, but if it's only the AC transmission system, there also the only substation and distribution above the transformer. So control system is most easier of high voltage DC system. High voltage DC system is popular for this accurate control system. Okay, stability of network very low due to line inductance and reactance. If you say the stability of network low due to the line inductance and reactance because it's present in AC system, but here also the much higher because low inductive and reactance. Okay, AC line is loaded up to 50% of its thermal rating, while DC line is loaded up to 90% of thermal rating. That means AC transmission line can take a load by conductor with thermal rating up to 50%. That's mean it take a power. If you also heat produce, also 50% load are possible to giving this conductor. But if it was a DC, it is DC, then we can use also the 90% of heats of this conductor. You can supply the power. Okay, so next video we see that which type of transmission high voltage DC transmission are present in India scenario. Okay, thank you.